Good morning, science friends. Let's start today with just this little warm-up. I'm not sure if this is in your notes packet or not. I believe it probably is. But let's look at these two guys. This is just a review from Punnett Squares that we've been working on. Determine what maternal genotype would most likely yield the offspring with such characteristics. Okay, so our offspring has little b, little b. Our dad has big B, little b. So we know that dad can donate either a big B or a little b allele, okay? Clearly, he gave that little b allele to his offspring, okay? So the mother also must have given a little b allele to the offspring. So the maternal genotype that would be most likely for that would be little b, little b. Okay? Now, are there any other genotypes that the mom could be? Yes. She could also be big B, little b. But to truly answer our question, would most likely yield, it's going to be little b, little b. Okay? Let's just do a quick Punnett square. Dad is big B, little b. Mom is little b, little b. It doesn't matter which one you put where. And so in this scenario, we have 50% of them that would come out like the offspring. Versus if you have the other scenario where dad is big B, little b, and mom is also big B, little b, you're only going to have a 25% chance that it would turn out with little b, little b. So this one with little b mother is definitely most likely to come up with that trait. So it's not really clear in this diagram. I'm assuming eye color is perhaps what that codes for, since the dad has black eyes and the offspring has red eyes. Okay, so that would be the phenotype. The genotype, though, is our letters, and that's what the question's asking us about. Okay, so today we are going to work on two-factor crosses. Now, in all of the previous examples that we have looked at, those were one-factor crosses. And one-factor crosses look at one trait. Okay, so this one was looking at eye color. Something might look at coat color in dogs or flower color in plants. And so it's looking at one trait. Today we're talking about two-factor crosses. We're looking at the likelihood of two traits being inherited together, okay? So this one is talking about round seeds versus wrinkled seeds. So this is a wrinkled seed and this is a round seed. And yellow seeds versus green seeds, okay? So we can see in this diagram that round is dominant, because the ones that have big R, little r, or big R, those are round. And so the recessive is wrinkled. And then the other trait, dominant, appears to be yellow. The ones that have big Y, or big Y, little y are dominant. And so then the recessive is green. The ones that have little y are green, okay? So let's look at this Punnett square and figure out how to do it, okay? I'm actually going to open a new page so I can walk through it step by step with you, okay? So both of our parents are big R, big Y, little y. So when we make a Punnett square for a two-factor cross, it's going to have a much bigger box. It's going to have 16 boxes. So it's 4 boxes wide by 4 boxes across. Okay? Now, the trickiest part, the part that you will forget on a test if you don't do a few of these as practice, is how to get what goes over the box. Okay? So I'm going to show you that. Do you remember the FOIL method in math? where you multiply the first ones together, and then the outer ones together, and then the inner ones together, and the last ones together. That's what we're going to do here too. So we're going to multiply the first one, the big R by the big Y. Okay? The next one, we would do big R by little y. That's the outer. Okay? Inner, we're going to do little r by big Y. And last, we're going to do little r by little y. Okay? Now, since this parent is the same, these alleles that go on the side are also going to be the same. And then when we fill in our Punnett square, we always want to make sure our R's go together and our Y's go together. So we're going to do big R, big Y, whoops, big Y. Big R from here and here. Big Y, little y from here and here. Okay? And keep going. It's a little bit time consuming. Make sure you're practicing this at home as well. Okay, so we've got our completed Punnett square here. Now, let's try to find the phenotypic ratios. Okay, I'm going to go back over to the screen because it's the other screen, the PowerPoint, because it's already got it drawn out for me with colors and shapes, so it's a little bit easier to see. But they've done it the exact same as us. Okay, so if we're trying to find the phenotypic ratios of this Punnett square, then we know that there's 4 possible combinations. You could have offsprings that are round with yellow seeds. You could have them, we see them here, that are round with green seeds. We see them that are yellow with wrinkled seeds. And we see them that are green with wrinkled seeds. So we've come up with all of the possible combinations of those. So let's see if we can count them up from this diagram. Round and yellow. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of those. Okay. Round and green. I've got 1, 2, 3. Round and green. Okay. Yellow and wrinkled. I've got 1, 2, 3. Yellow and wrinkled. And green and wrinkled, I've got 1. Okay. Now what you see here, we have 9, 3, 3, 1. Okay. That is a very common ratio. You need to memorize this 9 to 3 to 3 to 1 ratio. That is super, super important. Okay. Anytime that you have a 2-factor cross and both parents are heterozygous for both traits, that means they both have to be big R, big Y, little y. Both parents have to be heterozygous for both traits. Then you will always get a 9 to 3 to 3 to 1 ratio. Okay? 9 plus 3 plus 3 plus 1 totals our 16 boxes that we have here. The 9 is always going to be both dominant traits. The round trait and the yellow trait were both dominant, and that's where we had our 9. The 3s are always going to be one dominant trait and one recessive trait. So we had a round dominant with a green recessive here, and then we had a yellow dominant with a wrinkled recessive here. Those with one dominant and one recessive trait are going to give you your 3s in your 9:3 to 3:1 ratio. And then the one with both recessive traits, green was recessive and wrinkled was recessive, is going to give you your 1 in your 9:3 to 3:1 ratio. Okay? So this is the hardest Punnett square that you'll do. It's the biggest Punnett square that you will do. It is a little bit tedious. This one was nice because it already had the diagrams shown, which ones were round and yellow. But if you were working through that Punnett square like we did here, you would have to look and be like, that one's going to be like, that's round and yellow, that's round and yellow, that's round and yellow. If it's round, it's got to have one big R. If it's yellow, it's got to have one big Y. So you would have to look for those with one big R and one big Y. Okay, and you would see there that there's 9, round and yellow. And then you would keep counting for the other ones, round and wrinkled, yellow and wrinkled, and no, that's not right. Green and wrinkled, sorry, yellow and wrinkled, and then green and round. Sorry, yellow and wrinkled, and then green and wrinkled. So green and round, those are going to have 2 little Y's and at least one big R. So that's that one, and that's that one. So there's our 3s. Yellow and wrinkled is going to have 2 little R's and at least one big Y. Okay, so 2 little R's with at least one big Y. So there's our 3, and then our last one down there. Okay, so is a bit time consuming. Okay, now let me show you one more quick example on 2-factor cross Punnett squares. I don't think this one is in your notes, but I do want to show you a bit of a shortcut. Okay, so again, this one was 2 heterozygotes. What if we had maybe 1 heterozygote and then one parent that was, okay? So again, we're going to have to FOIL. Let's draw our Punnett square. You can just pay attention, or if you feel the need to copy this one down, knock yourself out. So we're going to have to FOIL big R, big Y first, outer big R, little y, inner is little r, big Y, and then last is little r, little y. Okay? Now, when we do this one, if we FOIL, we're going to get big R, little y, big R, little y, big R, little y, big R, little y. Okay? So, let's fill this out real quick. Now, I could keep filling out all of these bottom boxes, but all a Punnett square gives us is a ratio. And so the ratio is going to be the same. This and this and this are all the same as this first row. So you don't really need to fill them out because you're just going to get a ratio. We're going to have 1/4 that are round and yellow. Those are going to be round and yellow. Okay. These are going to be round and green. Oh, these are going to be round and yellow too, 2/4 or 1/2. And these are going to be, oh, they're all going to be round. This is going to be round and green. Okay. So 1/2 round and yellow, 1/2 round and green. But my point was you can shorten or simplify your Punnett square if all the letters are the same. Maybe this letter was different. Maybe you had one big Y here. Then just do those first 2 rows and leave these bottom ones out if they're a repeat. Okay? Usually if you had it there, it would be there as well. But to get your ratios, you can save yourself a little work that way. And that happens often. Okay? So, independent assortment, those genes, like we talked about yesterday, are going to separate independently. They are not inherited together. If somebody inherits the round, it doesn't mean that they're going to inherit the yellow. If they inherit the green, it doesn't mean that they're going to inherit the wrinkled. Those traits separate separately, okay, independently of one another. And so that's what independent assortment means. Genes for one trait do not influence another trait. Okay. Now, tomorrow we are going to talk about traits that are beyond dominant and recessive. So come back for tomorrow for that lesson. You'll have a great day. Oh,